Okay. My name is Tasha Wallin, and I currently spend my time helping clients set up their first website. I have a BFA in graphic design with an emphasis on motion and interaction design, but while still in college, I took a CS 101 course where I learned how to use Java and the command line interface, and I've been creeping my way through into tech ever since. Today, I'll be covering how I map out concepts in my mind when thinking about web development from the perspective of a beginner. When someone first thinks to themselves, I want to become a web developer, they may come to realize how many concepts and languages there are that go into it. Today, I'm going to discuss my way of thinking about how everything fits together from a big picture perspective with some extra details thrown in as we go along that I think are important. The first two categories that I use to organize things in my head are front end and back end development. So, front-end developers write code that controls how information on a web page presents itself on different web browsers and devices. These different devices, also referred to as client-side devices, may have content arranged differently depending on the size of the screen. The slide shows a desktop computer, laptop, tablet, and mobile phone displaying the same information, but the tablet and phone especially show the differences in presentation. Concepts known as responsive development and mobile-first development are two common approaches for achieving this objective for the front end. Of course, having an understanding and appreciation of graphic design skills also helps in this area. For the coding portion, the three main languages for front end are HTML, currently HTML5, CSS, currently CSS3, and JavaScript, currently ES6, which is short for ECMAScript 6. ECMAScript is the standardized specification for JavaScript. I said currently ES6 earlier because ES6 is considered modern JavaScript, and even though there are versions out there that come after, they're pretty much considered add-ons after ES6. So don't freak out if you see newer versions out there, just start with ES6 and build from there. Generally speaking, you should start out with a good foundation in HTML's semantic structure. From there, you can move on to styling and layout with CSS. And if you ever see a tutorial for web development that uses tables in HTML to arrange content on a page, just close out of it immediately. That is far from best practices nowadays for a lot of reasons. Once you have a decent handle on HTML and CSS, you can then move on to JavaScript that handles interactivity and other cool functions. So I'll go back to my cheat sheet and fit in the front end to that. Next up, we have backend. That's everything that's handled by the server, and I'll run through the finer details on those in a minute. But first, programming languages like Python and C# are considered backend languages, but there are many others. An interesting thing to note is that even though JavaScript has historically been a front-end language, it can now also be used for backend, such as with Node.js. Backend code is stored on your server and handles things such as databases and user connections, such as who has logged on to your site at the moment, or let's say that your user fills out a form on your website, and then your server sends you an email with that form's information, along with a confirmation email to the user who filled out the form, and so on. The backend does some really cool stuff. Backend programming isn't concerned with making things visually appealing, but rather with how things connect and work together. It's a good idea to at least have a basic understanding of command line interfaces, or CLI for short, along with a basic understanding of networking down the line, especially if you plan on managing your own server accounts. That being said, pick a language such as the ones mentioned here when you're first starting out. Python generally has a smaller learning curve when it comes to learning how to program, while C# is going to give you a much better understanding of how a computer functions. Node may be especially useful if you've already started picking up JavaScript for the front end. And then a few quick notes about servers. The image at the bottom right of this slide shows one of the many different kinds of server hardware out there, which is where all of your front end and back end code lives. Most servers run with an operating system called Linux, which can also run on your personal computer if you so desire. Linux is often represented by Tux the Penguin, as shown above my example of a server. Linux works with two different distributions, often called distros for short, such as Ubuntu, Fedora, CentOS, and the like, because there's no such thing as just Linux. Servers handle the storage and distribution of all content on the internet, including the World Wide Web. It's also worth noting here that the web is a part of the internet. They are not the same thing. All that being said, you can rent a server from a hosting provider, which you can then use to connect your domain name, such as www.example.com, to your front end and back end code, and that's how you get a website to work. So now I'll add my backend to my sheet. And then since we've gone over front end and back end already, full stack is pretty easy to describe. A full stack developer is a developer who uses both front end and back end code and perhaps even manages their own servers for themselves and clients if they're working independently. Back on my cheat sheet, I've wrapped the full stack box around the front end and back end sections to reflect what goes on there. It's important to note that you don't have to have the goal of being a full stack developer. If you get really good at front end or back end, there's just as much value in that as if you know both. It largely just depends on what works best for you. Before I continue on filling out my cheat sheet that I've got going, I want to take a moment to go a little bit deeper into a couple of concepts that you're more than likely to run into when learning how to code. The first concept is about frameworks. A framework is basically a pre-made skeleton for a related language. Instead of having to set everything up from scratch as a developer every time you set up a new project, a framework does the most common things for you and saves you time whenever you're building your projects. A framework also makes your code more efficient, more secure, and easier to debug because so much of the heavy lifting has been done for you already. The image to the right shows a structure in Singapore, which is kind of world famous for enclosed gardens, which often include trees, so they're really big. I think this is a great way to think of frameworks because your application is going to live inside the framework, much like there's going to be a large garden living within the structure in the photo. Some examples of frameworks would be Angular and Vue for JavaScript, Django and Flask for Python. Generally speaking, it's a good idea to learn the vanilla languages, in this case JavaScript and Python first, before picking up frameworks in order to have a better understanding of how they work. Which brings me to React. I'd originally believed that React was a framework for JavaScript, but evidently it isn't. Even reactjs.org says as much on their blog. It's actually a library. It seems React kind of blurs the lines between frameworks and libraries, so I wanted to take a specific mention of this here because it's so popular. It's really common for developers to use framework and library interchangeably, so I thought it would be a good idea to put this on your radar early. Put simply, React is concerned only with rendering the user interface and leaves many other aspects of development to be managed by other processes. So with that being said, a library is far simpler than a framework. Libraries do share similarities with frameworks in terms of faster and reusable code, but libraries are used to optimize only certain specific tasks that someone has already written for in your chosen language. I've used a photo of a bookshelf in this to help illustrate the difference between frameworks as well. While your whole project fits within a framework, a library only fits within a part of your project, much the same way a bookshelf goes into a specific room for a building. Technically, the big difference between frameworks and libraries is what's called inversion of control, or IOC for short, but that's more advanced than what I'm going into today, but that is the main difference. A couple of examples of libraries would be jQuery and the previously mentioned React for JavaScript and NumPy and TensorFlow for Python. So let's get back to the cheat sheet and finish it off. Last but not least, we have version control. Let's say you've done a great job so far in your project and then you just somehow break everything. You don't know what you did that broke everything, and now you have to spend a ton of time backtracking and trying to figure things out, and maybe that's time you just don't have. Or let's say you work somewhere where that tech debt has been allowed to accumulate to the point that an update to a critical part of your workflow breaks everything, and management is just demanding a fix right now. With version control, you can go back to an earlier version and try things out again. You can use version control for both front-end and back-end code, and that brings us to Git. Git is a very popular version control system created by the same guy who made Linux. This is done by creating a sort of warehouse for everybody's code called a remote repository that you can then borrow and change. And I'll get to that in a second. But first, for remote repositories, aka repos, GitHub is the most popular choice to store the remote repo that everybody then works from. Git and GitHub allow you to work independently of other developers on your own computer for your portion of the work. I'll give you an example of how it works. Git and GitHub you start out with your warehouse on GitHub, and then let's say that you want to contribute. You get the copies of all their code from repo with Git. And then once you have your own copy, also called your local repo, you can then make changes to their code and then give it back to them to look over and then add to their project if they like what you did. Other Git repo services include GitLab, Bitbucket, and SourceForge. And with that, version control finishes off our cheat sheet that I've been building throughout my presentation. Since it can handle everything a full stack developer does, I've wrapped version control around full stack development, which in turn wraps around front end and back end development. I strongly advise learning how to use Git and GitHub when you're still learning your first front end or back end language. It'll help show your progress as a developer from the very beginning, and will also act as a great backup whenever you inevitably break your code, which it's going to happen. So you might as well be prepared for that. I know I've gone over a lot of stuff during this talk, so I hope this helps make all of these terms a little bit less like fuzzy buzzwords. Everything I've gone over are useful concepts as you become more skilled as a developer. Once again, my name is Tatia Wallin, and I hope you found my talk helpful if you're just starting out. If you want the slides or cheat sheet used in this talk, feel free to pull them on my GitHub once I have them up, or send me a message and I'll send them your way. You can also reach me via DM on Techlahoma Slack, where I mostly hang out in Code Newbie and WordPress channels, or you can search for me on LinkedIn. I do my best to usually respond to anyone within a couple of days. Thank you.
Awesome. Thank you, Tasha.